Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over theoretical probability. So we've started a lot about probability and some of the language that we use, the likeliness of certain events happening. Today we're just going to be talking about theoretical. So theoretical means what is supposed to happen, because if we sit down and actually experiment and try out the probability, well, the experimental probability may be a little different than the theoretical probability. So the theoretical probability is what we've been talking about. It's a ratio, so a comparison of two numbers, of the number of ways that the event can occur to the total number of outcomes. So right here, we have how we find our theoretical probability. And if you remember, we actually wrote this down on our last set of notes. So the number of ways that the event can occur, and that's over the total possible outcomes. So we're going to stay consistent to that definition right there. When the outcomes in the sample space of an experiment have the exact same chance of occurring, then the outcomes are said to be equally likely. So remember, we used those words, the likeliness words. So whether an event was likely, we said as likely as not. So that would be the same thing as equally likely. So the probability of it happening is the exact same as the probability not happening. So an experiment in which all outcomes are equally likely, then we call this a fair probability. You can usually assume that the experiment involving coins, number cubes, those are all fair. So that means that a dice isn't going to have two number ones on it. We're going to say that there is numbers 1 through 6. They all have one number. It's a fair number cube or dice. So an experiment consists of rolling a number cube. We're going to find the theoretical probability of each one. So rolling a 3. So what we normally see is a capital P, and then in parentheses, what are we finding? And we talked about some of this last week. So on a number cube, how many 3s are there? There's 1 out of a total of 6 numbers. So this should be some review from last week. So the probability of rolling a 3 is 1 out of 6. Rolling a number greater than 3. So you want to think about all the numbers that are greater than 3. So 4, 5, and 6 are all greater than 3. So we'd see a capital P for probability of a number greater than 3. So there are 3 numbers out of a total of 6. Now don't forget, we do always simplify our fractions, because 3/6 is the same thing as 1/2. We can divide both the top and the bottom by 3 to get 1/2. So that would be an example of equally likely. Rolling a multiple of 3. So remember, we talked about some of these math terms last week. A multiple would be everything we multiply 3 by. So 3 times 1 is 3. 3 times 2 is 6. 3, 6, 9, 12. These are all multiples. So rolling a multiple of 3, well, remember, on the number cube or the dice, we only have numbers 1 through 6, so 3 and 6 are the only 2 numbers we can roll. That's a multiple of 3. So there'd be 2 numbers out of 6. And then notice both of our numbers are even, so we can simplify it to 1/3. So there's a 1/3 chance that we would roll a multiple of 3. We also talked about this word last week, a factor. So factors are what do we multiply 18 by to get 18. So I always start with 1 and 18. Then we have 2 times 9, and notice how I put them in order here. 3 and 6. I hope I have enough room. And there we go. So let's look at all the factors on the number cube. That is a factor of 18. So 1, 2, 3, and 6. So 4 of the numbers out of 6 numbers on that dice are a factor of 18. And then again, 4 and 6 are both even, so we can divide them by 2 and simplify our fraction to 2/3. So the probability of rolling a factor of 18 is 2/3. So again, all of these probabilities, these fractions we're getting are theoretical, what is supposed to happen. But if we sat down and actually took a dice and rolled it over and over, would we get a factor of 18 4 out of 6 times or 2 out of 3 times, the same fraction? Would that happen? Maybe, but maybe not. So the experimental probability could be a little different than the theoretical. okay? Sally and Lorena were discussing how to write the probability of rolling a 3 on a number die. Sally writes it as 3 over 6. Lorena writes it as 1 over 6. Who is right and who is wrong? So remember, rolling a 3, we looked up above, or we did the same problem up above. If we're just rolling a 3, there is 1 3 on that dice out of 6. So who is right? Well, I'd say Lorena, or Lorena. I'm not sure how to say her name. So Lorena is correct. There is only, and it does say explain, so that's why I'm going on here. There is only 1 3 on a dice. Therefore, the chances are 1 out of 6. Are 1 3 out of 6 total numbers. Okay, I'm going to pause there because I want you to try some of these on your own. Now down here, notice that they're asking for a fraction, then a decimal, and then a percent. So we practiced this last week as well. So you're first going to start out with a fraction. So randomly choosing a B. So we're looking for a letter B in the word algebra. So how many B's are there? Well, there's 1 B. Out of how many, oops, and there it already has it for us, the capital P and then the probability of finding a B. So there's 1 B out of how many total letters? A, L, G, E, B, R, and A. So that's 7 total letters. So the probability is 1 out of 7 chances. Now remember, to change that to a decimal, we would divide. So I'm going to pull up my Desmos real quick. Remember the numerator, the top number always goes first. So 1 divided by 7. We get a long decimal here. So let's write down 0.14. Let's round to the hundreds. And then don't forget to change this to a percent. We would move that decimal 1 2 places right. So as a percent, it'd be 14%. And if we needed to round that, we could take the next number next to that 4. So 1/7, 0.14, 14%, all of those represent the exact same thing. That is the probability of finding a B in that word algebra. So I'm going to pause here and see if you can figure out those last 4 examples.